Hello, today I will be walking you through how to graph a rational function without using a calculator with Zach.
So the first thing you're going to want to do to solve this equation here, 4x squared over x squared minus 9, is to find the domain. Now, that's the first step you should always go with whenever you're trying to graph any equation, because it's the simplest step to do, and it'll give you a great basis for the rest of it. Now, the easiest way to find the domain is to factor the denominator if it's possible. Now, luckily, for an equation like this, it's fairly easy to find the domain because you can factor the denominator through the difference of squares. Now, after that, all you have to do is apply the zero product rule, and if you remember correctly, that means that you set each term in the denominator, or the two factored portions, equal to 0. So, as you can see, set x plus 3 equals 0, then x minus 3 equals 0, and you find x equals negative 3, x equals 3. Now, that's how you know where the equation can't exist. Now, the next thing you're going to want to do is write out the domain in the proper notation. So the proper notation for this would be negative infinity, comma, negative 3, union, negative 3, comma 3, union, 3, comma, infinity. All right. So the next step is to find the intercepts. And for that, I'll hand you over to Gary.
So, we're finding the y-intercept first, and for this you need to set x equal to 0. So here we have f of 0, and you just replace the x values with 0. That gives you 0 over negative 9, which equals 0, and that means there's a y-intercept at 0, 0. To find the x-intercept, you set y equal to 0. So basically, you set the equation equal to 0. And then you multiply the denominator out, so you get 0 equals 4x squared. This becomes 0 over 4 times 4x squared over 4, because you want to get rid of the 4, which equals 0, and then, as you can see, x equals 0. For the symmetry, I'll hand it off to Zach.
For the symmetry, what you want to do is find if f of negative x is equal to f of x. So, what you're going to do is first find what is f of x. We already know that it is 4x squared over x squared minus 9 because it was given to us. Now, next we find f of negative x. This means you plug in negative x anywhere there is an x. So 4 times negative x squared over negative x squared minus 9. Now, when you solve this out, it will of course equal 4x squared over x squared minus 9. And because there is no change, the function is symmetrical about the y-axis, meaning it is an even function. So the next step is just to find the asymptotes. And this is pretty easy because it was really just part of the domain. So first you're going to look at is setting the denominator equal to 0. So this is x squared minus 9 equals 0. So you can switch that over to x squared equals 9. And the square root of x squared equals the square root of 9. So x equals positive and negative 3. So you know that there's going to be vertical asymptotes at x equals 3 and x equals negative 3. Now if you think about the domain, that makes sense, because we already showed that the graph can't exist at 3 and negative 3. Now to find the horizontal asymptote is pretty easy on these two. And that's because if the powers are equal, and as you can see they are for 4x squared over x squared minus 9, you just have to divide the leading coefficients. So you take 4 over 1, which of course is just equal to 4. Now the next good step to take is just to draw in all of the asymptotes on a graph. Once you do that, you'll have a nice little bare bones for a graph.
Next up is end behavior. So for end behavior, we're going to look at the limit of f of x as x approaches infinity, which equals 4 on the graph, and the limit of f of x as x approaches negative infinity, which also equals 4. The reason why they both equal 4 is because there's a horizontal asymptote at y equals 4, and the end behavior of the graph cannot go past 4 as it approaches infinity and negative infinity.
Now for the next couple of steps, you're going to need to know the derivative of the function. So I've drawn out here how to find the derivative. Now pause it now if you need to find out how I did it, but it's very simple. It's just the low d high, high d low rule. So you take the denominator, multiply it by the derivative of the numerator, and then you do vice versa, and then you put all of that over the denominator squared, work that out, negative 72x over x squared minus 9 squared. So the next step is to find the intervals. Now the first thing you're going to need is the derivative, which I already showed you how to find. Now what you're going to do is use the horizontal asymptotes as sort of markers. Now you're going to find any number that goes from negative infinity all the way to negative 3, a number between negative 3 and 3, and then any number from 3 to infinity. You're going to plug that all into the derivative. If it's positive, it will be increasing. If it's negative, it will be decreasing. So we know that it will be increasing from negative infinity to negative 3, decreasing from negative 3 to 3, and increasing from 3 to infinity. The next step is to find the local minimum and maximum values. Now the first step to doing this is to find the derivative and set it equal to 0. Now as you can see, all of this will simply work out to 0. So you know that there will be a critical point at x equals 0. But to find if this is a minimum or maximum, simply draw out a small number line like this, with 0 in the middle because you know it is the critical point, but endpoints at negative 3 and 3 because you know that of course these are asymptotes. Now, you take any number from between these here. For me, I simply did the derivative of negative 1 and the derivative of 1. Both of these came out to negative numbers, so you know that they are in fact lower than 0, where the critical point is, so you know it is a local maximum. The next step is to find the concavity. But first, you must find second derivative. We have drawn out here how to find second derivative. Pause video now if you would like to follow steps. Now for the last step, we find the concavity. So you do this by, once again, just drawing out a number line, as you can see here. So negative 3 and 3 other points because those are asymptotes. Then you take the second derivative of any value within those intervals. If they are positive, you know they'll be concave up. If they're negative, they'll be concave down. So you know that from negative infinity to negative 3, it will be concave up. From negative 3 to 3, it will be concave down. And then from 3 to infinity, it will be concave up.
So the last step is to finally graph our function. So we know there's a max at 0, 0, and we know that it's going to be concave down. So we can draw our graph like this. And we know that the point up here is going to be concave up, and that reaches the asymptote of negative 3. And this one starts at the asymptote of 3, and it is concave up. And there's our graph.